All right, it's all working good. I'd like to thank John for putting me between you and lunch as well, because it's always the... this is sort of a random collection of information. I will try to race through to the end where it's the new stuff, but there's a little bit of repeated and distilled introduction information that I put into this respinning of this talk. I've done similar ones, but this one's been updated from, it's been 2 years ago since I did the talk. So about me, there you go. I've done stuff for a while, and I do things for the Octo project, and I do a few other things for AMD. Again, we can save time. I'm going to cover quickly the goals, technology. I have done actually presentations probably on every one of these individual topics that will take 45 minutes. And I did a report card on myself for my published goals of last year, which was, I think a pass, maybe barely, 40%, is that a pass? Then some use cases and examples. Let's go right here. Overview, containers, meta-virtualization, and open embedded. The vision, and I grade the vision as well in my status update as well. So it's to leverage what we know open embedded and the Octo project can do to become actually a sort of a platform of choice for building containers. Also, I would like to simplify the container in VM build and deploy. Still going on. Easy containerization for whatever recipe you might be building. And also direct deploy to images or a management framework. One of the two of those is done. And the big one would be to maybe get to the point of, we did the binary distro work, Michael, last year doing with the sort of the tech fund funding, but I still need to get around to enabling sort of binary artifacts in reusable base containers, so you don't have to build them all, and we can just have our own, if you will, run files to create things. And create some defined and tested container and virtual machine host images. I won't give you a sneak preview of the report card. That is what I'm mainly going to be talking about later. So the question is, as John trolled, why would you use Yocto open embedded for containers, right? Isn't it all about the application? What do you care about building from the source? And I always say it solves the problems that you don't know you have yet. And that would go back to all of the different security and CRA things that we've been talking about, where you can, when you're leveraging those core OE and Yocto capabilities, you are going to get the things that you don't know you need yet. The other thing that I would say is that if you've ever seen me on the meta-virtualization mailing list, I'm adamant about not picking a particular runtime and going all in on it. So it's building block technologies where I'm not picking the one that you need to use, and then we're not locking in on their technology train. And so also the elements of the solution they're spread all through the ecosystem. Meta-virtualization pulls in big chunks of meta OE for things it needs. It uses the OE core capabilities, and it adds the stuff on top. So meta-virtualization, the quick timeline summary is the layer was started for virtual machines, hence the name, but now it's actually probably more containers than virtual machines. Zen is getting a little bit more attention lately, if you're interested in that, for automotive and some of the applications like that. So I ended up having to learn how to build and maintain Zen because the people that were doing it before disappeared, and as Richard would sigh, it always ends up to the maintainer of the layer to either get rid of it or pick up the slack. So I now know how to upgrade and maintain the Zen bits. Over time, the capabilities have increased with the frameworks, more complicated runtimes, improved out-of-box configuration, those sort of things. And so you can do deeper solutions and integrations. And then now there are, just as of this year, some reference host and container images with configurable stacks, and I will plumb it into binary outputs and things like that. There's the timeline that I always do. You can see it goes all the way back to 2012, and I added a few things off the end here that I've added recently. The container host references. If you see a container runtime that's not a sort of really, really niche one, that's not in meta-virtualization, let me know. I'll probably, we had somebody ask about LXD, but of course it's not really a thing anymore. So maybe it's Incus, I don't know. But and then finally, one of the things I'm working on that I've been trying to do for probably since 2020, what I call the cross-container install. So to be able to build and write the containers directly into the root file system at build time. I've probably had it working for Podman for about 2 years, but Docker is the problem. And to go with the vision of not picking the runtime and locking you in, I've sort of been unwilling to do it until I can make it work for all of the runtimes in meta-virtualization. And to do it without special permissions and needing root daemons and all these things that you'll see various other solutions for. One thing I wanted to cover, because this will be recorded and we can use as a reference, to keep my sanity, there is a sort of an update cadence to meta-virtualization. I go through and I update pretty much every recipe in meta-virtualization around the M2 timeframe and then once more before release, about a month before release. So I called it M3.5. That allows me to actually do feature development, avoid the churn, little breakages in the middle. I test the whole stack because some of these things are quite complicated. And then I do the whole thing for releasing. So, of course, bug fixes, continuous, I'll merge those. But, the big scripted recipe updates and bumping source revs to random things, I have my own script to do it. So I do that, and I only do it about twice a release. And that way, it's not constantly changing and breaking. I push all changes to master next for, probably annoyingly to some people, a undefined amount of time before I'm either not traveling to a conference or I know I'm going to be around and break, and then I will merge it to master and then back to the stable branches. I focus, due to the other things I have to do, both for my employer and for the project, I focus on the master branch almost exclusively, the current release, and if people need updates to the packages in the stable branches, then they should definitely nominate them and I'll merge them without question. But I don't have time to go back and do all the stable bumps to all the recipes that are in the releases. You can get a hold of me on the mailing list, IRC, Metavert, and I do actually maintain some other open source projects using pull requests, so it's not out of the question that I could also take pull requests to meta-virtualization as an example. We'll skip. These are questions that I tend to answer, and my plan is to try to document these and or do reference images to answer the questions, so I don't have to all the time. So we get, I just want to pull random external container into the build. You'll see various workshops and slides and presentations and layers that do this. My answer to that one is, you can do that, but I won't help you do it because you're going to run into problems. How do I install? I had somebody trying to how do I install Docker to my image? Well, that is documented in meta-virtualization. It should just work. His init was seg faulting, and it wasn't really Docker. That was his part. So I was helping him debug that. So anyway, these are the sort of things that the goal is to get the reference images and the readmes and the stuff in meta-virtualization better to answer it, so I don't have to, and get that cross-container install done, because every 6 months somebody pops up and says they want to do it. What I cover in meta-virtualization is build and deployment. So for our definition, build is the compilation of the construction from source for a container or guest. And the future, I would like that to include building from OE-generated artifacts, hence the binary distro stuff that we were interested in. Deployment is the installation and running of a container on the target image. So not only being able to pull it on, be able to cross-install it, set it up for auto-start, boot, and it's there, right? So you don't have the first boot kind of pull and install. The container and the guest build, OE Core, of course, has the base support. The techniques to build the containers and guests they've evolved over time. It used to be sort of iterative multiple builds, external assembly, we multi-config. I created the OCI image type, and now there's virtual machine image formats. But in that sense, trying not to recreate anything in meta-virtualization, just reusing what is available from OE and the Yocto project core values. I have a bit of trouble with some of the multi-config stuff if you look at how I fix Zen image assembly, so there's still more work that I have to see what we can maybe improve in OE core to make that a little bit easier. Yeah, the challenges, here you go. They can be, I find, even I do this like every day, and I still find some of it clunky and confusing, regardless of which of those choices that you made. And it's certainly not end user versus developer friendly to figure out how to build a containerize something and get it running on your OE derived image. There's a murky path to binary container construction and reuse because of all the different technologies at play and the way it's spread through the ecosystem. And the sort of your commonly cited guides don't apply. You can't just say from OE base, take whatever, blah, and build an image, right? So we have to document it ourselves, and I'd like to improve that as well. And the build time and reuse is still questionable because the artifacts aren't properly stored. The container or guest deployment install, I'm going to say this is not standardized, and I really don't think it should be because it varies based on your container runtime or your hypervisor. Some of the options for doing your guest deployment install is the direct or cross-image install, so it's available for startup. You can do a registry or an artifact push and then a pull. You can do it through a management framework, Kubernetes, K3S, and then everything else, I call it a custom hack. So, get mad at me or not. The challenges are that for the most part, almost none of this is cross-friendly at all due to daemons, root capability requirements, licensing, reproducibility, everything. I hacked up Docker for about 3 months to try to get it to not need all the capabilities it needs to run a container just to write to the root file system. I got it almost working, and then it seg faulted. So if anybody is good at debugging Golang seg faults, you can come talk to me, because I was joking with everybody. I have a set of tabs open in a window in Chrome with one of them is literally titled How to Debug a Go Seg Fault. And I look at it and I get depressed, and then I move on to something else, and that's why it's not done yet. Or I'm now going to revisit maybe some other techniques again. But anyway, so that's the problem. And I find there's requirement creep because everybody says, well, I want to install it, but now it needs to auto run, and I want to set up the network. And where do you draw the line for the deployment versus making the tools available, being too prescriptive and too overly configured to make it not useful for different scenarios? Meta-virtualization in general, its challenges. Upstream is moving extremely fast for these, and that's why I only do the updates a couple times in our development cycle. The languages, I end up doing, I think we did a lot of the more complicated Go recipes originally in meta-virtualization because everything was written in Go, Rust, and sort of I end up having to troubleshoot just the build versus the runtime, and that's not where I want to spend my time. I found that the deployment and reuse of the different components, if you go look at this CNCF landscape, they say, there's a CRI, a container runtime interface, there's a networking interface, there's a this and that. It's kind of like the OSI model for TCP/IP. It looks good on paper, but it gets all messy and blurry in the middle. So how to factor those blocks out into package groups and things that you could then pull into your own image has always been challenging because of different naming, different technologies, everything. And of course, there you go. I've always looking for contributors and help with the hard to solve issues. At one point last year, I basically started refusing to take any more updates to meta-virtualization until somebody helped me get Ceph building again, because it's a clustered file system I know nothing about, and it was way out of date. It was using an EL branch, and it just wouldn't work. And I think Tim Orling stepped up and helped me get it working, because it's like I don't need source rev bumps on trivial recipes. I need somebody to help me debug sort of these hard things, because it's not technically useful for me either to use it, but I also don't want to drop it because I feel the need to keep the things that are in there working, because very little has ever been dropped from meta-virtualization. We've kind of hauled it along and upgraded it. Unless the upstream project completely disappears, I've kept it going, whether it's something that I use on a daily basis or not. So this is my status, my report card on what I said upcoming was in 2024. Streamlined build by a BB class. I think it's done. It's sort of not done. There's more, but I wanted to pass, so I gave myself a done on this one. Direct image install. That's still in progress. It's only been 3 years. Multi-layer OCI container image build. Didn't get to it. Maybe I will eventually. And by that, I mean not multiple open embedded layers. I mean being able to do a base OCI layer and then the union layers on top of it, so we could reuse the base layer and just have smaller Delta container updates. And it enables a whole bunch of things for us, so I haven't quite got to it yet. I have image assembly tools and ways to do it, but we need to define the layers, what goes where, and then write the config. And it's not rocket science, but it's not trivial either. Reference container host and app, so that's done. You'll see that's what I'm going to talk about shortly. Target container on host rapid test, not done yet. If your architecture matches, it'd be nice to have like a sort of a run QEMU like interface to just test your container versus having to spin something up and test it. And then framework test, deployment streamlining, I did that by retesting like K3S. So I called it done. Again, I don't know. I sort of passed. Maybe I got a C- on that one. On the vision, first class CNC in progress. That'll never be done. Simple inherit to generalize containers recipe of it, sort of done, in progress. Direct deployed images, in progress. Available binary artifacts, in progress. The only thing I'd say is reusable base containers. The definitions are there in meta-virtualization. And the define and tested container VM host images, done. So I guess I'm still failing on the vision. But we can't be all thought leaders like Mr. Philip Ballister. He's a thought leader. What's new and soon to be new? I don't know how I'm doing for time. Oh, 17 minutes, good. What's new for developers? As usual, there's recipe updates. This is in sort of what you'll see now and what's been done since in the last release. The host image reference with flexible components is there. I changed the networking configuration and flexibility. The image bundling for Zen is now different. It's sort of, you can actually have an external image or an OE built guest in Zen and bundle it into the thing. And the reason that was important for Zen is there's a lot of RTOSes and things that are running for automotive, for example, that don't get built by Open Embedded right now, and you need to bundle it onto the image to test it. I reorganized and created new package groups. I did a whole bunch of README updates to show how I tested all of the different stacks. The kernel configuration updates and consolidation is done. So if you built, I'll show you shortly, the Docker host image and you ran their kernel config test, it should come back fully green. So I made sure that all the runtimes had a configuration available that would have everything running. And there's a new reference developer container, which is literally a container with a tool chain and things in it that you can push and use on the target. What's new for users? There's the reference containers, there's a base, there's actually a systemd container, if you're interested in that. I have a little example of it. And there's a developer container. There's simplified configuration now to choose what you want to run. Sort of there's extended runtime and registry samples now. I tried to document more of the workflow and then the new guess. And there's more that I will now hopefully get started now that we're getting into that M3 timeframe of the current release. What's coming? One that I'm interested in getting myself is, how we can do bitbake package index, and it creates you a package index, which you can then run a web server against, and you can pull it onto your target. Well, I want to do the same thing where I can create a container registry from your deploy directory. So you can build your images, run your target, and then just pull them onto your running image for easy startup. It's mostly done. I have a little bit more work to do, but that's one that I wanted to do. The cross-container install, almost done, right? Auto start of the container, so that goes with the cross-container install. Sort of the image bundling needs work. I have to go back and revisit multi-config to try to figure out if I can make it work better. The streamlined container build via BB class, I still need more work. Well, I guess this is everything I said I failed on, right? So you can tell I'm planning on doing everything that I failed on last year, this year, and we'll see if next year I give a status report that says I failed on it again. But the plan is, that's my plan. If you have anything that you think meta-virtualization should do, there's the mailing list, find me, or IRC. All right, and now I race through to get to the point where I can do some examples in the next couple minutes of some of the new things that are there. So there is a new container image host, and I have a link to the README that I wrote about it when I was creating it. So it's a sort of a flexible image definition that's suitable for building. It's a host image that you'll run on your target that can run different types of containers. I factored out all of the different bits of meta-virtualization, the networking you want, the container runtime, the runtime binary into sort of virtual providers, if you will. And then you can just set a container profile in your local.conf for your distro, and then it selects all the right ones of those, and then your image gets built from a single image definition, which was painful. So here's an example. Like here's one for Docker plus a DevTools container. So all you actually have to set in your local.conf is your container profile Docker. That could be Podman, it could be Containerd, it can be K3s. There's a whole bunch of ones that you can set, and they'll stitch together the components in sort of the best known working configuration. Like if you do Podman, you're not going to get CNI, you're going to get Aardvark and their networking tools instead of CNI, for example, right? And so this container DevTools base is something that I was asked to do, and it's just a sample container that actually has an editor and GCC and some different things in it. So if you want to spin up some on-target development, it's a reference one. So I bit-baked both of those after setting that. In this example, and I did remember to take my username and credentials out of the thing. And actually, if you want to see my flailing, you can always find my Docker hub, and you'll see the various pushes of these sort of, some of them giant containers to and fro. So, and this is the part that I want to streamline, right? So I have to go into temp deploy images. I copy it to wherever in this example, Docker hub. It doesn't have to be there. It could be your own private registry. It could be whatever. We copy the container out, and then I then boot QEMUR in this example. You always have to crank up the memory, and the image definition of container image host has enough extra space built into that image definition so that you can actually store some of these images. So, you boot it, you log into Docker, pull my container DevTools, and then I just started a shell, right? So, in theory, if everything's working, all you would have to do to get a suitable host image to run Docker containers would be set container profile equals Docker, and then build the container image host, and you can do it. And that I didn't bother showing you that it would build and stuff, because what's in the container is actually less interesting than, in this case, the host example. Here's an app-based one that I did. There's one called Container App Base, which this is the attempt to streamline it, where you can simply define the binary to run, the container app, the packages to install, and I made a default that just runs the date command. So there's a sample base container, which is sort of as small as it can be with minimal functionality. You bit-bake it, and then I built it with Podman, but then I showed I could run it with Docker, so, it's hard. And then, you can, if you change the entry point, of course, you can run it. So you can see it's using about 2.6 megs in this example. And that's not me going to extreme effort to try to make it a really small image. And then if you don't do anything, it just puts out the date. Oh, did that? I jumped. No, I didn't. It puts out the date, which was the sample ad for that. So here's one that, I don't know, might be more interesting, a more complicated case where I created a systemd-based container. And this actually puts the init system. So it's more like an LXC container without needing to run LXC. It puts systemd as the init manager into the container. You can see it's a much more complicated launch. I tested it with all the runtimes because you have to sort of grant and take away some permissions and capabilities and different things to make it run. But once you start it up, you can see it shows it ran sbin init. You can create yourself some users, and then you get the IP address, and you log into the container. I SSH into it here, and you can see it's sort of a multi-user, multi-process container that's running, because sometimes, depending on what you're trying to containerize, it might really want systemd services or units or how it started. And rather than re-implementing and factoring it into an application container, this might be the way to go. So I put it there as a reference. And that's it. I think I did it in time. All right.